Hello, everyone, and welcome to episode 17 of our Pure Logic playthrough of the Artisan of Glimmith. We have completed 150 puzzles so far. We are still working in the precision area, and there's a couple of hidden altars here that we need to start with. Turn our colors on. All right, all regions must have an area of exactly 9. Exactly 9. Okay, so let's think about how this could work. Now, first of all, we'll just look at there's 36, so we're looking at 4 regions. So my first question I'm thinking of, could this region and this region be the same region? And the answer is no. Because there is no way for me to connect these together and not cut off this one. So like if I come around like this is now a dead region. This can't be the same because it's crossed. You can't have a region cross the line. So this is necessarily a separate region, and this is a third region. And can these two regions be the same? And the answer is going to be the same no, because no matter how I do it, it's going to cut that one off. So this is a fourth region. So these are our 4 regions right here. Now, let's see what that means for some of these other locations. So for this boundary here, we're probably going to need something like this. And on this boundary here, we're going to need something like this. How many is this? That's 8. So I have to do like that. This feels very close to forced. And then this one would have to reach around here like this. And that's 8. Ooh, boy, then how do I get these two? So, if this does something like that, and this can't reach over there, can it? It can, but just barely. So that doesn't work. So this border here is not between this one and this one. Is it between these two? That's too long. So who's on the other side? I guess this could be like this. And this could be like this, but that's too long. This is at 9. This is at 11. This is too long. I guess I could take these out. Yeah, this is feeling like that's what we have to do. Now, how do we get there? How do we get there? So playing around with it, we can see that we've got to have, here's our 4 regions. Let's get a blue, purple, green, and yellow. And each of these regions have to be on other side of the line here. So starting with this line, if this is the region on this side and this is the region on this side, this is just too small. And the most I can do is add 1 and 7. So that's just not happening. So this is not the region on this side of the line. There is no other color that can get to this sideline except for the green. So this is now forced. So which color is on this side of the line? Over here. And the only one that can do that is the blue. Now blue is trapped. It's at 4. It needs to get to 9. And this one has to grow there. That's the end of that one. It can't go there. Oh, this can't go. Yeah, it does go here. So on this side has to be green. So these 3 have to be green. This can take one more. There we go. So we kind of figured it out, but going back to core logic, again, we want to solve this with logic, not just, but I will play around with the puzzles. That is a gold, but we're going for beyond gold. And we will do this puzzle right here. All right, every region is size 5. We've got the Gemini, they got to be the same shapes on either side, and we've got Delta, got to be different. All right, my eyes are kind of drawn here to the middle for some reason. Lots and lots of things saying these are exactly the same, exactly the same. But what does that mean? And this one is different. So this region is the same as this region. Is the same as this region. It's not the same, it's the same shape. This region is the same shape as this region, is the same shape as this region, is the same shape as this region, same shape as this region, which is the same shape as this region. These two are the same shape, these two are the same shape, but these two are different. So I'm just going to draw something in here. If this were our starting point, this fails right here. We can't draw that one. Okay, these have to come out like this, which means this has to have a length 2 somewhere on it. It could go down like this. That's cut off. So if these are connected, I could do something like that, something like that. Are these all fit? Using a Y pentomino? And that'd be a Y here somehow? I'm not sure, but maybe like this. Like this, I don't know. But that's the kind of thing we're looking for. So again, I'm playing around with the shapes, just to see what kinds of possibilities can we work with. What we do know is that it does have to extend out a little ways like that. So here's my first question. Can all 4 of these be part of a region? And it be like a P pentomino? If we're saying the shape is a P pentomino, then this would be the P and this would be the P. And these, and it doesn't matter where I draw this, we always have a section that comes out. So the shape is not a P pentomino. It's not going to be any kind of W. I can't do that. It's not going to be a U. Could it be an F? You know, something like this. This one fails. I think F is it's difficult in the center to get two Fs. Because as soon as like even, I mean, and it doesn't matter which way I do it. Like this can't be an F anymore. So F is off limits. Z can't, Z would normally look like this, Z. I could do it in here, but you know, that's dead up there now. So the Y is looking like it's the only one that actually could work. Oh, I didn't look at Z like this. But how is this going to be a Z? This can't be a Z. So yeah, that doesn't work. I don't have my list of pentominoes up. There's only a hand. I mean, there's not that many of them. All the different shapes. I mean, I guess I could try to draw them out down here. We got the P. We got that kind of shape. This shape for the Y. We got the F shape. Why is this one? Oh, it's I'm sorry, here, like that. We got the long line. The long line doesn't work because these aren't long enough. We've got the Z. We got the W. We've already said the W's can't work. The plus, we can look at plus. Plus isn't going to work because it cuts that off. Or the X. What other shapes? What other shapes can we do? I think we're really close to. Oh, the L, the long L. Which we need to look at that one more time. I think those are the universe of shapes. Oh, the U. I don't have a place to put it. We've already looked at it once before, but that one. And that's not going to fit in there either. So the only two that even have a chance of fitting in here are the Y and the L. So we could do the L out this way. That works okay. And then this would have to be something else. Doesn't have to be an L. But that's doable. The one we saw before was the F. And it's either here or here. Oh, this is critical. Okay. These cannot be, this is the piece we need to look at. This one and this one are not the same region. If they're the same region, this is a contradiction here. This is the key to the puzzle. This region is not this region, but this region is is the same as this region. So this is lending towards what we had for the L's, because if I make this the P, I can make this a P, but now I can't do it on this side because this has to be a P and this is a orphan cell. So as soon as I have this kind of scenario where this shape is not this shape, I've got two questions. One, does this shape have to go in here? Can this be a separate shape from this? Can I draw that line? So let's research that a little bit. If I make this a line, this has to grow, this has to grow. Oh, the V is the other shape. Now this shape and that shape can't be the same. So this could grow here, but then this would have to grow like this. And this one couldn't go up there, so it would have to go like this, like that. Oh, I made a V. So like that. So that kind of works. Doesn't make me go in the middle. So this one could come up here like this. Still the same problem though. So maybe this one just does an L as well. But this has to be the same and this one can't be the same. So this shape and this shape couldn't be the same shape. So maybe this is a long one. Nope, because then that one can't be. Oh no, but this one has to be the same as that one. Well, that's a contradiction as well. If this shape touches this one, then it's the same shape as this one, but this has to be different than that one. So this one cannot take that one no matter what. So I could come here, but not any further, which then means this has to come over and come down. But now these two have to be the same. We've linked them together again. So we're creating an equivalent. Even if I don't connect these together, if I connect this to this is false. So I have to have a line in here somewhere. And I think that line's gonna even have to be here. But it's at least here. That this one cannot communicate with these over here. Because these three must be different than these two. And the reality is, yeah. So these three are the same. That's the same. That's the same. That's the same. This is hard coded. These are the same. This and this are the same. That line has to be there. And now this has to grow. So it grows. It can't grow into here, so that's hard-coded. This has to grow. This has to grow. This has to grow. These are the same shape. So there's no way this is forced. Okay. Now over on this side, all of these shapes are the same shape and they're not L's. So are these F's or Y's? This is not going to work for a different reason, but anyways, something like that. The question is, what shape is this? It's not an L. So it's either a Y or a T I don't think a T works here, though. What about S? No, that won't work. It feels like F is the only thing that really does work here. You go F and F and F. Or is it F like that and F? Maybe, that one does. I gotta be careful not to. Like this would create a problem here. I could do something like that. F, F, and then that's an F. Okay, how many? 1, 2, wait, hold on. 10. So that's exactly 10. That's 15. So all that works. And then it's just a question of just pushing stuff together. But is that forced? That's the question. This is forced. I'm comfortable with the L's over here. And this is not an L. So we've eliminated the U's, the P's, the T's, the X, the F. No, the F. Yeah, the F. The F is not possible. We're considering the Y. The Y does seem possible. The W, no. The long I does not work here. I is not a possibility. L is off limits because it can't be the same as these. So I think it has to be F. These have to be Fs. So I'm comfortable saying that that's true. So this is an F. It comes out. One of these is not Fs, Ys. I'm sorry. It has to be a Y. This one is going to have to be this. That has to be that situation. This will have to be one of these two. Which means this has to go this way. It can't be here. It's going to have to be here. This has 10, so this goes this direction here. This is going to be snake around. It can't go down there and like that. This is an F. This one of these has to come down. This is also an F. And it can't go this direction because that'll mess up. So it's going to have to go this direction. But that's a problem too. That creates a... How do I get an... Oh. Well, let's see. Is there a different way to do the F like this? The Y. I keep calling it F, the Y. I can do the Y like this. Yeah. We're going to have to do it like that. And we have to keep it... We cannot have this cut off this section. So this can't be the long line. So the question is could it be this be the long line? No, because that doesn't connect. So this is the long line. This is that one. That's the way to get that. So this one's here. This takes up these. This takes up these. This takes up these. Yeah. That was a good puzzle. That was hard. All right, let's look around. Here we go. We got a puzzle up here. 9, precision 9, and we're doing exactly three regions. We got the deltas. They have to be different regions. And we have the Gemini. We got some same regions. Okay, this is looking fun already. So this region is not the same as this region, but this region could loop around and be that region. That's possible. Similar here, this region is not that region, but this region could be this region. But here's the gotcha. These two have to be the same. So let's talk about, we got an odd number of regions. 2 of the regions are the same. 1 of them is different. 2 are the same. 1 is different. So this represents exactly 2 regions. So this is this. Absolutely. Because it doesn't work otherwise. Because 2 of the regions are the same. And this region is not that region, is not that region. These are not 3 separate regions. Now, I don't know if they connect like this or if they connect like this. This makes more sense to me. But these 2 have to connect somehow. Is it possible they connect like this and then this one goes up like that? Now, this region is not the same as this region. So this can't go up. So this is a different region altogether. And yeah, this doesn't work. This doesn't work. This goes like that. Now this could go up here, or it could go up here like this. No, it can't go up like that. But again, this and this are the same. This one's different. So it makes sense they would go like that. And then this one wraps around. These have to be the same shape. So somewhere I've got to come up with like a, for this green, it's got to have something like that. And then this would have to grow. So this would have to grow. Like that. But this has to grow here. And that one can't grow. If I grow it here, this one can't grow either. So these are connected. And again, this can't be on both sides. And it doesn't matter if it was this one, because the region here has to get out. So the third region is up here somewhere. So this is... So maybe we start with something like that. Extend, 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 extend. There we go. All right. 35 out of 35 with a +2. Is there anything else to look at on this one? I think we have completed this region. Let's zoom in, look around, because they hide stuff. They hide stuff really sneakily. You have to look like back inside windows and look inside the windows, make sure there's nothing. Ah, here we go. Precision 21, and it's a 42. So this is interesting right here because this has to be the same as this. And as soon as that's the case, I can say this has to be true. And I can fill the rest in. So there's a rule. I forget the different types of puzzles. I've seen them in Sudokus and stuff. But if you have two regions that have to be fully connected, you cannot alternate more than once. And because this color had to be on both sides, in order to connect here to here, it has to go around the entire edge. And once it does that, that's all the space. All right. There's a puzzle in there too. What is going on? These guys are... Oh, I've already done that one. All right. Maybe that was the last puzzle? Makes me wonder if I've missed some other puzzles somewhere. This game is so tricky, hiding puzzles. I'm probably going to have to do a whole episode just searching for puzzles. Anyways, I think we're going to stop right there. It looks like we're ready to start this next path. It's going to be the polyomino. Polyomino. Sounds fun. We'll read that rule next time. Folks, if you're enjoying this series, please like, subscribe, comment, do all that stuff. Let people know you like it so other people can find it. I appreciate you. Catch you next time.